National Mathematics Day celebration, year 2020. The great Indian mathematician Srinivasa Ramanujan, who was born on 22 December 1887 and departed us on 26 April 1920. His history: he was born on a Tamil Brahmin Iyengar family. At age 13, he mastered the advanced trigonometry. At age 17, he calculated the Euler-Mascheroni constant. Ramanujan failed on his Fellow of Arts exam in 1906 and again a year later. He lived on extreme poverty and often on the brink of starvation. In 1910, after a meeting between Ramanujan and founder of Indian Mathematical Society, he was known as a researcher in mathematics. Personal life: his father Kuppuswamy Srinivasa Iyengar, his mother Komalatama Ammal, married to Janaki on 14 July 1909. His first problem was solved for x is equal to, and the answer was 3. He calculated using nested radical. Hardy and Ramanujan had highly contrasting personalities. They nearly spent 5 years in Cambridge collaborating with works. The most intriguing work or formula for infinite series of pi. There was a formula for estimating pi. Mahalanobis, the great Indian statistician, and Ramanujan, the great Indian mathematician, tried to solve a problem together. Ramanujan's notebook. While still in Madras, Ramanujan recorded the bulk of his result in 4 notebooks. The result in his notebook inspired numerous papers by later mathematicians trying to prove whatever he had found. The Hardy Ramanujan number 1729. It is the smallest number expressible as the sum of 2 cubes in 2 different ways. 1729 equal to 1 cube plus 12 cube, which is equal to 9 cube plus 10 cube. Posthumous recognition: 2011 125th anniversary of his birth, Indian government declared the celebration of National Mathematics Day.
Let us see some of the contributions of Srinivasa Ramanujan to number theory. Magic squares. The simplest magic square problem is to fill up the cells in a square with 3 rows and 3 columns with numbers 1 to 9 such that each row sum equal to each column sum equal to each diagonal sum. The magic square given in the chapter 1 of his famous notebook is given in the first example. The second one is the magic square matrix created using his date of birth, 22nd December 1887. Ramanujan gave the following formula for the given magic squares of type 3 by 3. Theory of partitions. Let P of n denote the partition function n defined as the number of ways of expressing n as a sum of natural numbers less than or equal to n. Highly composite numbers. A number n is a highly composite number if d of m less than d of n for all m less than n, where d of n is the number of distinct positive divisors of n. One of the highly composite numbers calculated by Ramanujan is 67463283888800. These are some theorems based on highly composite numbers. There are infinite number of highly composite numbers. Successive highly composite numbers are asymptotically equivalent. If q of x denotes the number of highly composite numbers less than or equal to x, then limit n tends to infinity q of x by log to the base x is equal to infinity. Expression for pi. For the transcendental number pi, Ramanujan has given several formula of them are listed here. Diophantine equations. Let's see some contributions of Srinivasa Ramanujan to Diophantine equations. First is Ramanujan's number 1729, which is the smallest number that can be expressed as a sum of 2 cubes in 2 different ways. Diophantine equation. Ramanujan found out the parametric solution to the Diophantine equation x cube plus y cube plus z cube is equal to w cube. Symmetric equation. Ramanujan proved that this equation has only one integral solution. Ramanujan's equation. The Diophantine equation x square plus 7 equal to 2 raised to n is called Ramanujan's equation. Triangular numbers and Mersenne numbers. Numbers of the form m into m plus 1 by 2 is known as triangular numbers and 2 raised to k minus 1 is known as Mersenne numbers. Let us consider the question which triangular numbers are also Mersenne numbers. By equating these two equations we led to Ramanujan's equation. Thank you.